Hello students. In the last class, we have discussed about nuclear fission and fusion, and we have discussed about various types of fission reaction. Today we will be discussing about the fusion and few numerical points related to energy. So today we begin our lecture with one numerical. In this numerical, we are given a equation which represents the fission of uranium-235 as bombarded with one neutron gives krypton plus beryllium with releasement of three neutrons and energy. This is the equation. We have to calculate the energy that is produced. So for it, we have to calculate the mass defect. To calculate mass defect, we have to evaluate the initial mass and the final mass. So initial mass. In initial mass, we will be calculating the mass of uranium and neutron. So mass of uranium plus mass of neutron. That is 235.04 and mass of neutron is 1.008. That gives us 236.048. This is the initial mass. Now final mass. In final mass, we will be adding up the mass of krypton, that is 91.8954, plus mass of beryllium, that is 140.9177, plus 3 neutrons. So we have to multiply a mass of a neutron by 3 neutron. So this comes out to be 3.0261. On adding this, we get 235.8392. Now we have to evaluate the mass difference. So mass difference will be equal to initial mass minus final mass. So 236.048 minus 235.8392. It gives us 0.2088. So this is mass difference. This mass difference corresponds to the energy equivalent. So now we have to evaluate the energy which we were asked. So energy. For calculating the energy, we know that 1 AMU produces 931 megavolt energy. So 0.0288 AMU will be producing energy that is 0.2088 multiplied by 931 MeV. That will give us 194.3928. So that much amount of energy is produced in this reaction. Now this was the one numerical which gives us idea that how to evaluate the energy released in a reaction. Now we will discuss about nuclear fusion. As we have discussed that it is a reaction or it is a process in which two smaller atoms combine together to form a larger nuclei with the releasement of large amount of energy. But for this, there are some special conditions. They are that it is possible that the nuclei of lighter nucleus can combine to form a nucleus of heavier atomic number atom, but for it requires a large temperature. Means for this process the temperature which is required is very high. Due to this condition, presently in the recent times it is taking place naturally and it is taking place at sun. Means as we say that sun is a source of heat and energy. So this being a source, it carries out this process. On the basis of this process, it is termed as a source of heat and light. Now we will discuss that what are the various examples of fission reaction. First we define it. Now we will discuss about its example. For example, we know about deuterium when two atoms of deuteron, that is heavy hydrogen nucleus. Deuteron is heavy hydrogen nucleus, that is H21, and it is represented by small d. So reaction carries out as when two atoms of deuterium combines together, it forms helium accompanied with neutron with 3.3 megaelectrovolt of energy. So the stated reaction represents that how the nuclear fusion occurs. These reactions can be produced also in the laboratory, but for that we have to accelerate low atomic number nuclei in a particle accelerator, and the high energy projectile is made to strike on the target made up of that particular material whose nuclei can fuse with the projectile nucleus. So this is how it can also be carried out in the laboratory. Now we will discuss that how this process is carried out in sun. So now we will discuss about sun. We know that the sun has an enormous amount of hydrogen. So we can state that sun contains a large amount of hydrogen. And this hydrogen is accompanied with high temperature. So as we said that it contains large amount of hydrogen. So these hydrogen are also present in their isotopic form. Means natural hydrogen is present but its various isotopes are also present. For example, deuterium, tritium, these types of isotopes are also present. In the sun, these small isotopes of hydrogen atom collide together and fuses to form a bigger atom of helium. And with the formation of helium each time, tremendous means a large amount of energy is also released. That we say that sun gives us heat and light. So that amount of energy that is released in the large amount is in the form of heat and light which we receive. Due to this energy, sun shines and the reactions are as follow. As we have discussed that it is deuterium, these again combine together to form helium with enormous amount of energy. As we discussed that it also contains tritium. So again this heavy nuclei of atom of hydrogen combines with tritium to form helium in the sun. But this time it also releases a neutron, again accompanied with energy, that is in a large amount. So nuclear fission or reaction inside the sun is taking place due to the isotopes of hydrogen, and because of this sun emits radiations of different wavelengths of all the sun's radiation. Means there are infrared radiations, ultraviolet radiations and visible radiations. The same process which we have discussed about the sun, it also occurs in hydrogen bomb. But in the sun we discussed that hydrogen is a amount or hydrogen is a substance which is taken as a principal source. But in hydrogen bomb, these substances are replaced by other ones. So let's discuss about hydrogen bomb. Hydrogen bombs have a basic principle of nuclear fusion, and a hydrogen bomb is nothing but it is a nuclear fission reaction which is not controlled. Means it is in an uncontrolled manner, because if it is controlled then it should not cause that much of destruction, but it causes much of destruction to human life and human property. Means it is not controlled. So it can also be defined that the principle of hydrogen bomb is uncontrolled nuclear fusion reaction, and it is consist of an arrangement of nuclear fission at the center, and it is surrounded by a mixture of heavy nucleus of hydrogen atom, that is H21, and lithium isotopes. In hydrogen bomb, basically we have discussed that there is a fission center. So fission in center gives heat, that is high temperature plus neutrons. But the neutrons which are produced are used to convert this lithium. As we discussed that lithium is also present. So this lithium accompanied with neutrons convert it into tritium, that is H31 accompanied with helium, and whole this process is accompanied with large amount of energy. Again, this tritium, we said that heavy nuclei of hydrogen is also present. So this tritium combines with that heavy nuclei of atom, and it gives us helium with one neutron and energy. Again, this heavy nuclei of atom fuses with another same nuclei to form helium with energy, and tritium combines together with another tritium again to form helium accompanied with two neutrons and also energy. So these reactions shows that how the hydrogen bomb is responsible for such a destruction. Due to this process, as we said that it is a house of destruction, means it leads to high temperature. Due to this high temperature, these are commonly known as thermonuclear reactions, and these are just so called due to high temperature. As we have discussed the various reactions which are taking place in hydrogen, During this reaction we have taken the tritium also. Like here we have taken the tritium, here we have taken the tritium. Again, here we have taken tritium and here we have taken tritium. But while discussing its construction, that what are the various things which are present in hydrogen bomb, we didn't said that tritium is also present. We said that only lithium is present and hydrogen, means heavy nuclei of hydrogen atom is present, means these two atoms are the in the construction part, means these two constitute the bomb. Tritium is not a part of it in its constituents because it is prepared in the hydrogen bomb itself, and it is prepared in the hydrogen bomb itself because tritium is very unstable. So if it is there, then it will cause the instability in that bomb. So it is prepared in the bomb itself. Thank you, students.